So let's go through what we've done so far in this mobile application development module. So starting off with, oh, by the way, I've also got some recommended books in case if you want to go further down, because remember this is an introduction to the concept of app building or mobile app development, and we're using Flutter as a language and Dart as a language and Flutter as our system for the UI library to realize these applications. And we started off with very basic. We looked at understand the user requirement first. That was our first action. Then we looked at conceptualizing a mobile application. We looked at usability, as in how to make the application user-friendly. Then we looked at a very nice concept called the design thinking in order to understand and design our application. Then we moved on to prototyping. We used a tool called Figma. It's free, it's online, and it's a wonderful tool to visualize your application to understand how it looks on the mobile phone. Then we looked at the theory of color. It's called the color harmony, and how color can be used for a mobile application. But having said that, mobile applications have something called themes. So when you have a logo or a corporate color scheme, you need to derive your theme based on those colors, right? So that's why we need to understand the color harmony very well. Then we also, with that, we started the Dart programming language. You realize it's a fantastic language. Like JavaScript, like Java, like C#, like Python, it's a serious language. It has all the things that we learn in other languages, including object-oriented features. And we did some heavy lifting with Dart. It has lots of features where you can do asynchronous programming, that is to consume APIs and whatnot. Then with that, we introduce ourselves to Flutter, which is a UI framework based on the Dart programming language. So we realize under Flutter, everything is a widget. Widget is derived from a class, a parent class, and what we're doing here is we're putting widget inside another widget, kind of a functional programming. So one completes and then it goes to the parent. From there, it goes to its parent. So likewise. And then we looked at, first of all, how to lay out something from the beginning. So there are things like safe area of the mobile, something called scaffold, where we get the minimum requirement for a mobile application, like the app bar, bottom navigation. Under Android, there is something called a fab, and there is a sidebar, things like that. So some of them may not be suitable for Apple or iOS. That you will design when you're designing platform specific things. You will be designing all those. So we did a lot of work with Flutter, lots of layouts. And then we looked at something called state management. And that is where because under Flutter, we go from one screen to another screen. Every time you go to a new screen, everything that you put in the memory goes away. Just like how you apply or access a website. When you go from one page to another page, the web server doesn't remember anything from the first page unless you pass that information. So of course, in web design, we do different things. We use cookies, we use sessions and various things. But in Flutter, we use something called state management. Now, in order to do that, of course, Flutter has its own state management, where the widgets can be stateful or stateless. We use a fantastic library called getX, which make our life very easy for state management. In fact, getX is very flexible. It has lots of different features. Apart from state management, it has a navigation system, a very easy navigation system. It also supports a multi-language, right? So we wrote a Sinhala and English application, if you remember. So that's what to do with getX. And finally, last week we looked at forms. Now, all this time up to this, we were only showing information to the customers or the users. Last week, we looked at how to get information from the users by way of forms. There are two form elements available, one with validation, one without validation. And it's pretty straightforward. Only thing is you need to have some sort of a state management system. So we couple that with getX in order to get the state management incorporated to the input elements. So today we are looking at another very big topic under any, in fact, under any software development application. It is called testing. All right. But testing is very important due to lots of different aspects. One is the cost of the software. It's very big when it comes to testing. And there are specific testing mechanisms available for mobile applications. Now, what we're looking for now is not generic, but very specifically on Dart and Flutter. Okay, so let's see what are the things available under testing and why this is important. Okay, so under testing, like I said, we are looking at software testing specifically. So my plan is to go through these areas. Now, if you take any software development project, testing is very important. And most of the modern software applications come with frameworks. So it's common for Flutter as well as for Dart. And this framework includes some sort of testing mechanism as well, right? So in our case, under a mobile app testing, we go through something called unit testing, widget testing, integration testing, and there is a concept called TDD or test-driven development, which is actually part of the unit testing. So this is a concept. We'll see what it means. Then there is also something called mocking dependencies, especially when you are dealing with API integration. Pretty much every mobile application has to live with API integration. Generally, this is done by two parties. The UI or the Flutter party will be one team. Backend API development will be another team. So until the backend is up and running, you need to use something called mocking. Right? We'll see how it is done. And when it comes to complex project where lots of changes going on, we use another concept called CI, a continuous integration. And in fact, it is connected to another term as well, CI/CD, continuous integration, continuous development, where as a developer, when we push our code to a code repo like a GitHub or Bitbucket or something, the app will automatically get rebuilt and will be pushed to maybe the testing department or the staging servers, even deployment servers, things like that. So we can automate the deployment of our application. And there is also something called code coverage. We'll see what it is. Then there is, like I said, the framework has lots of different ways of testing. So there is something called test suite, and also grouping our application so that we can test it group by group. Remember from day one, I said Dart and of course Flutter has a comprehensive way of documenting our application and generating the documentation out of these comments, right? Now we can go one step further by integrating some of the test cases to the documentation. Meaning when you are writing the code, you can give testing instructions within the documentation as well. So that with one command, you can extract the test cases from the documentation also, right? So now remember, when we were building the Flutter applications, we were using Visual, right, from Microsoft. And in my case, I was using the Edge browser because it was faster in rebuilding, right? So when you do that, the browser has lots of other plugins where you can use for testing also, right? And if you are using so our tools also come up with various development tools available, by the way. So for debugging, holding the code. So all that is very important because sometimes when something goes wrong, we may want to pause our application and then investigate things like the variables and some of the other things to see what is going on, right? So it's important to use the right tool for this. Otherwise, we'll be wasting a lot of time just looking at the source code. Now, let's start with this interesting chart. Now, on one side, on the vertical axis, we are looking at the relative cost to correct a defect. Now, what does that mean? How much money is required to correct a defect? Defect means some problem, some issue. So, how much money is required to correct if something goes wrong? This may be anything. So, I prefer to look at it from the dollar point of view. So, and then on the horizontal side, we have the development phase. So if you break down any programming project, you can identify there are requirement capturing phase, there is a design phase, then there is a coding phase, and then there is a testing phase and handing over to the client. We can call it deployment or operational phase. Now, if you find some issue during the requirement phase, the cost of fixing is very, very low, right? That's why it's very low on the left corner, less than $20, maybe 10 maybe, right? So it might be, now you might think, okay, what does this cost mean? It's about for 1 hour or maybe for 1 day, what is the cost? Now let's take it as 1 day, $10 per 1 day, let's say, is the cost of fixing a problem or a defect during the requirement phase. Okay, so we found the problem and then we can fix that. It's not very expensive. But when it comes to design phase, maybe you're looking at developing the screens, and then if something is wrong, we have to redo the screen. So that might require, rearranging and inserting something, removing something, whatnot. So that is expensive than the requirement phase. So for us to fix a problem during the design phase, it is almost double the cost of the requirement phase. When it comes to coding, let's say you started coding and then something is wrong. You found a problem there. Fixing that will be much more expensive than design or requirement. That's why the line is going up now. And after you're done, you're given the program for testing. Look at that. Costing is very, very high, right? Very, very high. And look at the last one. This is extremely high. What does that mean? When you build the application and given to the client and the client finds out something is wrong, that is way more expensive. Sometimes you can't even put a dollar figure there because then the customer has lost faith in you or your team. The customer might tell his friends not to buy any software from you, right? They might return the project to you. So you may have to return the money or something. So that's why it is very, very expensive when the customer finds defects, right? So we must do our best to fix whatever problems we have before giving it to the client. Here's another interesting chart. So there are three graphs here. First one, the blue color one is number of, or rather percentage of defects introduced in this phase. That is how many defects are introduced to our project. Now this is by the way the project, okay? And then the yellow color shows percentage of defects found in this phase. So this is the introduction of defects, found defects. And then the red one shows the cost of repairing the defects. Now, if you can't find it, we have a serious problem, isn't it? So you need to first find if there are any defects and then fix it. So the different teams are working in a software development company. There is a marketing team who brings the deal. Then there is a business analyst team who is documenting the requirement of the customer. Then there is an architect converting the BA into something technical. And then there are developers who build the project. And then we have QA, the quality assurance team, testing the project. So that's how a usual software development system or a team works. So if you look at, if you start from the blue color one, number of defects introduced. Now look at this. During the coding, of course, lots of defects are introduced. Now, how can you reduce that? There are 85% coming here. This is where the experience is coming in. More experienced people you have, less number of defects introduced during this phase. But it won't be zero, it will be something. But 85% is the number of defects compared to the rest of the phases. This is where most of the defects are introduced. All right. And as you can see, when it comes to unit testing, it is coming down very, very significantly. Under functional testing, under field testing, and post-release, it's very, very low. Now, this is also why we need to design unit testing, functional testing, and field testing. More you do, less number of defects you will find. So that's the blue color line. And the yellow color line is the number of defects found. So under coding, for example, this might be found by the QA or the coders themselves. Very low during coding, right? Because when you are a coder, sometimes your focus is coding as fast as possible. Again, when you are experienced, there are certain things that you must incorporate when it comes to coding, so that you will introduce least number of code in the beginning itself, right? So you see the yellow one is going up and going up. So this is very good because we find issues or defects during unit testing, provided we write unit test for our code. You see, it's very high here. If you write, you can find it. And under functional testing, you find some more debug, no bugs. And then field testing, you find the largest number of bugs or defects. But under post-release, This is with the customer, you still find, but very low. If you find more defects here, well, there may be lots of reason for that, but comparatively, they are very low. But look at the red color line, which is the most dangerous one, very similar to one we saw previously. Cost to repair defect. During the coding phase, it's about $25. During unit test, it's about $100. During functional test, it's about $250 per defect. This is, okay, per defect. And under field testing, it's about $1,000. And after giving it to the customer, look at that, $16,000 per bug for a defect. This is why, as a manager in a software company or a project manager, you need to make sure this cost is as low as possible. Because this cost, if it is going up here, you're not making any profit from your software. Now, as developers, we need to know this issue as well. So you can start from the coding phase itself and see, okay, how can I reduce the bugs? Now, this is where your experience and documentation, previous documentation experience come into play. If you document your best practices, you will end up introducing less bugs to your project. All right, with that, let's start with our first one, unit testing. What does that mean? Unit testing is about testing each individual function of your application. Now, if you notice, when it comes to Flutter, we write classes, isn't it? We were writing classes for widgets. Then we are also writing classes for various functions. Like if you remember, I wrote a class to connect to a remote API to download data. So that was a class. Yeah. Or maybe we write a class to build another widget by incorporating multiple, say, data set and things like that. So once you write that, you can test these individual units. Yeah. And make sure you run the unit testing before you integrate or give it to somebody else. So while writing the code, you can write the unit test also. Now, if you look at the best practice, our focus is testing the behavior of small isolated units of code. And then we use something called assertions to check the expected outcome. So we give, say, for example, I write a add function. So when I give two numbers, it should give me the sum. I know I can expect the value or the answer when I give two numbers. So assertion is a function where I can say, right, the input is 2 and 3, and the answer should be 5. So that is called expected outcome. If 5 is not coming, my algorithm is incorrect. Yeah, so the test will fail. So I need to go back and see, okay, what was wrong? So unit testing is something that we do for each unit. Then comes a very interesting one. This is actually Flutter specific one called the widget testing. Remember, in Flutter, everything is a widget, right? So, oh, by the way, now there's a keyword here. In isolation, what does that mean? We are taking each individual function or a method and test it in isolation. Separately, we are testing. Same thing can be said about the widgets. We take each widget and test it separately. Okay. Now, Flutter has something called a Flutter test package for doing exactly this. We can simulate button clicks. We can do all kinds of stuff in order to test our widget. For example, there is a plus button. Let's say there is a swipe button. things like that. We can simulate it using the Flutter test package as if someone is using the application, and then we can have a expected behavior. Now, there may be other requirements, like, for example, connecting to an API or loading data from the local database and things like that. We can simulate all that using something called mocking. We'll talk about that in a minute. Third one is called the integration testing. That is, after you put things together, it may be widgets, it may be other packages together, and then you test it. Okay, so there is one called Flutter drive command that is available for us to do the integration testing. So under this, we are looking at the flow of our application, as in starting from the login screen maybe, or the demo screen, login screen, and from the login, what do? You go to the dashboard maybe, or multiple screens maybe. In fact, there is also a beautiful package called the Flutter driver that will allow us to go through the navigation, multiple screens, so that we can have a look at the entire application. Remember unit testing? So those are the three, by the way, testing systems we use: unit testing, widget testing, integration testing, right? Now, coming back to the unit testing, the concept is called the test-driven development. What does that mean? This means you first write the test, not the code. Okay, so you write the test first, and obviously it is going to fail because there is no code, and then you write the code. Write the test, then write the code, not the other way around. Okay, so once it is running, you do something called refactoring. You improve the code. Now, this is also known as stub-based programming, where you write the function only, maybe with a return or something, and just to see whether your planning or the architecture is working. If it is working, you can go in and then start writing the code. Okay, so the whole point here is your code is testable from day one, from the beginning. That's the concept here. Okay, so the simplest concept when it comes to TDD is to write, and obviously test is written and it fails because we don't have any code that is doing some work. And then you go write it, write the absolute minimum, and then come back and refactor it, as in you improve the code. So this is TDD. It's also known as a test first development. Yeah. So you write the unit test, start the unit test, code it, and then you refactor it. Come back again to the test and make sure it is successful or it works. Right. So if you look at a flow chart, this is what happens. You start, add a test, and execute the test. It fails, obviously. Make changes to the code, right? And then execute the test again. If it fails, make change to the code until it passes. You go back to another test, right? And this process is known as refactoring. So the cycle is about writing a test, make it run, change the code, repeat the process, right? So this is also known as this three-color, like a signal line. Red is to writing the test that fails. Green is to make sure it works. Refactor. Purple one is to make sure your code is better or eliminate redundancy or improve your code. Now, let me show this again. There are some misconceptions about the TDD. People might think, oh, why are we even writing tests? Because we know our code is working. No, your code is working now, today. It might not work tomorrow, maybe once you introduce some other function, or when you do some integration, or when you deploy, it might not work. So we have no idea. So by writing the test along with the code, everyone using your code can run the test automatically. So this is a very automatic thing. So when you run the test automatically, wherever it fails, it'll show you, it'll pinpoint you exactly which part of the program is failing, right? So it's easy for us to find out which part of the program is failing and then go and fix it. Next comes mocking. Remember, most of our program depend on other external things like APIs, device peripherals like the camera and things like that, or maybe reading some files from the disk and whatnot. So when you are writing the code, maybe none of these things are ready. Images are not ready, API is not ready, maybe in your emulator, you don't have the camera or, whatnot. So we don't know whether these things are ready. In order to test your code, we use a concept called mocking. In fact, there's a package called Mockito. It allows you exactly that. So what you do is you isolate the external factors into a different set of code. Maybe you write some more classes, right? Providing these services through something called mocking. So your real code will have no problem. Let's say you want to connect to an API, download some data. So you write that code and now you want to test it, but you know the API is not ready. So what you do is you write a Mockito class where you submit or where you provide that data to your real code. So your real code thinks the data is coming from the real API, whereas it's actually mocked. Yeah. So this is another very important aspect of testing. So if it is working, we know your code is correct. Your code is working, right? Then you can move on to your rest of it. So once the real API is ready, all you need to do is replace the mocking with the real URLs and other data files. Continuous integration is some sort of an automation for your testing. Now, this won't work if you don't have your unit test, if you don't have your TDD concepts in place. So what continuous integration does is it runs your test automatically and then find out whether the code is okay or not okay. If the code is okay, it will go to the next step, right? Maybe pushing to another server, like a staging server or a deployment server, right? Otherwise, it will not update the live server. Now, this is important. You know why? Let's say we have a working application running in the deployment server and you are doing some changes. Now, if you might do some testing and whatnot, and you are happy about it, and you are pushing the code to the live server. What if that breaks the live server? Your customers will not be able to use your application, isn't it? Because something is broken now. So if you use CI, it checks the server first, actually tests the code first to make sure there is no problem with the existing running code automatically. And if there are errors, it will stop proceeding and it won't stop the live server for any reason. So using CI, you make sure your customers who are already using the system are not interrupted, right? Now, this process is connected to source code repository system. If you are using GitHub, it has something called actions, GitHub actions. If you are using Bitbucket, Bitbucket has another similar thing called the Bitbucket actions. Now, there are also other software like Travis, for example, where you use to do this. Now, you will not use this with the program that we are doing here, but it's good to know that these are the things used by the companies in the market, right? So it's pretty complicated. So CI will be able to run your application on multiple devices, multiple configurations, multiple integrations, and everything is automatic. Of course, you have to write the scripts and the code, but once you do that, it's fully automatic. And the job of the CI is to make sure that your running servers are not interrupted. That's the whole point of CI. And another interesting concept is code coverage. Now, what does that mean? Remember, when you do the Figma screens, we come up with all kinds of very interesting features, right? And then under TDD, you may write parts of that code also. But for some reason, you may not cover everything that was planned originally. How do you know that? Whether you have not covered everything that was planned originally. Now, to do that, you use something called code coverage. So the code coverage goes through your entire project and say, okay, you have not done this piece, you have not done that piece. So in a very colorful manner, sometimes even statistically, it will show you how many features are still pending, right? So this means, let's say your project requires 100 features and you have only done 40. How do we know? We have no idea by looking at the code, right? But when you do a code coverage test, you will get to know. So again, there are packages, applications that can help you with do this also. So the whole point of code coverage is to benchmark and measure the effectiveness of the code base, right? Now, this is also known as a white box testing. When it comes to testing, there is black box and white box, by the way. White box is where you have access to the source code and generally done by the developers, not the QA team. So here, when you do this, it will tell us which part of the program or the project is completed and which are the features that you need to work on. So there are some levels when it comes to code coverage as well. Branch coverage, function coverage, statement coverage, loop coverage, and also condition coverage. And then there is also last one, finite state machine coverage as well. Now, each one is about testing how deep you are gone inside the code and develop these things. Right? So the whole objective here is to see what is pending, what is still pending. This is very important for project manager as well. So you may promise some features to the customer and you might not know because you're too busy coding. You might not have an idea about which one is not done, right? So rather than giving it to the QA and then waiting for their input, you can do it yourself as a developer by running through something called the code coverage test. So the advantages are it is quantitative, meaning it gives you numbers, right? And also it gives you test cases. I mean, you need to be writing the test cases. But if you're not done that, it shows you where you can add your test cases. Also, there's another one called the dead code. Dead code is the code that you've written but never use, or useless code, right? So we might have like a, if-then statement somewhere where you are not using it, for example. Now, here's an example showing you in multicolored what is going on, right? What is covered, what is not covered, and what may not be used at all, right? Each color represent some state. And here's a report, by the way. So 42.9% requirements does have test. And these are the test cases. Test per requirement, 0, 1, 2, 3, like that. And then requirements per test. The other way around. Requirements with test, test with requirements. Right? So some of the statistic depending on your program, what application you are using for code coverage testing. Sometimes actually most of the time, your IDE is equipped to run this also. So you can use your IDE and say, look, give me a test coverage report. And the next one is managing or organizing your test into groups. Under Flutter, we call them suites, right? So there you can say, now for example, there may be, you want to test the login process. So you have a group called login. Or maybe you might have a group called user management. That will include registration of users, login users, password resetting, remember me function, removing users, disabling users, all that come under the user group. So all the testing can be there. So now under that, you might have multiple classes, multiple units, multiple widgets doing this, but everything is grouped together, right? Or you can say the group of books or book group, for example, for a library system. Everything about the book can be there, adding books, removing books, all that can be under that. So grouping gives some sort of a planning mechanism for us to do our testing. And this I explained earlier. So now in the beginning itself, we said you must learn documentation, right? That is automatic documentation of your code. So there are 3 slashes when it comes to Dart. That is what we use when it comes to documentation. There are some best practices. I think shared some links on this as well. So read about documentation best practices and start from day one. That shouldn't be the last thing you do. That should be the first thing you do. Start with the documentation. Why? Because you can also include some test cases in your documentation so that you can automate this also, right? If you remember, we were using Dart doc package to generate automatic documentation. And the last one is the DevTools. Tools coming as part of your IDE, maybe the browser, maybe the simulator, emulator, whatever it be, or even the real device. Now, if you're using an Android device, you can turn on debug mode. Okay, here's a website showing you how to enable the USB debugging mode on Android phone. By default, this is turned off. You have to turn it on, right? And also, by the way, it depends on the Android version you're having on your phone. So it might be a little different. Just do a Google. It'll show you how to do that, right? Let's see. This is Samsung Galaxy S8, S8 Plus. So you go to About Phone, Software Information, Build Number, and then here you have to tap 7 times here, right? About Phone, Software Information, 7 times you have to tap. 1, 2, 3, 4, 5, 6, 7. And then you get this screen. It'll take you to developer options and then turn on the USB debug. After that, when you plug the phone to your laptop or your desktop, you can then build your Flutter application, run it on your physical phone, right? It'll run there. Now for Galaxy S7, it's almost the same, yeah. So generally it's under About Phone and build number, and then you tap 7 times and then you will get there, right? That's how it works. So if your mobile version is not here, just do Google, you will be able to find it there. See here, it asks you to type the code. What is this phone? Oppo. Right, 7 times additional setting. You have to go to additional settings and there are develop options. You have to type this code and then only turn it on. Because by turning on developer mode, you are actually reducing the security level of your phone. That's why it's hidden. So be careful. After you've done your debugging or development, you should turn that off. Right? Don't keep it on all the time. Right? So different phones have a different way of doing it. But I'll share this link in your LMS to have a look. So the dev tools are available depending on your platform, whether it is a browser or an emulator or anything else. In fact, some of them are available from your IDE also, right? All right. Now, those are the test mechanisms and features that we have. And how do you actually run the test is the next question. Now, in order to run the test, you need to open a terminal. Okay. So for basic test, you type Flutter test. Right. This is the basic unit testing. Right? If you remember, we did a similar thing for Dart, isn't it? Same thing. They're using the Dart test package here. And if you want to do a widget testing, you say Flutter test, but you need to give the name of the widget also. Now remember, widget test is a separate class you are writing. Now in this example, I have a class called widget underscore test dot dart inside the test folder. Now generally our test cases have the underscore test in front of it. Now let's say you have a user widget that you want to test. So the user underscore test. And that class is inside the test folder. Okay. And remember Flutter Drive, this is for integrated testing, as in entire navigation can be tested. Now there, you have to do this Flutter Drive dash dash target equals test driver and then the app. Now here, it'll start from the beginning and automatically go through the whole application in order to do the testing. One last thing that you need to remember when it comes to testing is mobile applications or rather mobile phones. There are thousands of different devices available out there, right? They differ from the resolution, screen resolution, width and height. They differ from screen density, number of colors, and the capacity to store information. Also speed, as in network speed. Yeah. Some phones have 3G, some have 4G, some have 5G. So some latest phone, let's say if you have a latest phone and you're testing your application on the latest phone on 5G network with a large screen, everything is fantastic and smooth, but your application is used by a large population of the country who doesn't have the latest greatest. They may have a 3G older phone model with an older Android version. Yeah. So what you can do easily is you can emulate that older phone in your computer and make sure it is tested. Yeah. So if it is working there in the older phone, it works on other phones as well. All right. So let's do a unit testing example. So I'm going to do, I open my VS Code, it's blank now. So Shift, Control, and P. I'm going to create a new Dart project. This is to show you how to do unit testing. I'm going to say console application. And then I need to select the folder. So I'm going to go with this one. And I need a name. So I'll call it unit test 1. I need an underscore and press enter. And here we go. It is creating a project for me. And if you notice the left-hand side, all the code is here. And under this, I have a bin folder, but I also have the test folder, right? And if you notice, this program has a underscore test.dart. So this is my main code, right? And this is my test code. So you notice I have a calculate function. It is testing, which is here, right? So under, actually, this is my main code, bin and lib. I have my library, which is which contains my calculate function. So when I call this, it'll return 6 into 7. That is what it does. So it's a very basic program. I'm using the default version. So let's try the default version. So now in the, okay, 3 files, isn't it? This is my main code that does nothing other than showing hello world and also calling the unit test calculate. Okay. So when I run this, I should see the usual output, which is 42. So the lib does 6 into 7. So 6 into 7 is 42. So let's change this and see what happens. 5 into 3. Right? I need to go to this one and run again. Yeah, I get the answer, 50. All right. So now when I do that, okay, I need to go back to my original one. 6 into 7 was original. So run again. I get 42. Oh no, actually this one. No? Let's test this one. I need to run this one. Let's stop this and run this again. Oh, the output, sorry. The output is what I'm looking for. Okay, I have number 42. Now, let's run the test. Okay, how do you run the test? Now, for that, I need to go to the terminal. Oh, by the way, if you look at pub spec, you notice here, there is a module called test. Now, this is required for unit testing. Now, by default, it is already there, right? And now I go to terminal, and here I'll say dart test. Okay, it's a green, all tests passed, right? Let me close this. Let me go here. So it is multiplying 6 into 7, and the test is expecting 42 as the answer. And yeah, I am getting a 42. So let me go here and change this to something like this, 5 into 3. So I should get 15 as the answer, but I'm testing for 42 as the answer. Now my test should fail. Let's see. There we go. it fails. It says expected 42, actual 15. And where is the issue coming? So this is the program that is failing, line number 5. And okay, so to run this test again, yeah, we can do this. So it says some tests fail. So it's not green, it's red. One fail. Okay. So if I say here, 5 into 3 is 15. Yes. So now let me run again. All tests passed. It's green now. Now this is a very simple unit test that we tried. Yeah. And I'm using Dart, but well, because Dart is a code we are using anyway. So it's the same thing. All right. So that's a very simple example when it comes to testing, unit testing. Let me see whether I can do a widget testing. Let's go to Shift Control P. This time I need a Flutter project. I'm going to say, give me an empty project. Let's call it widget test. Okay, let's call it widget 1. Because underscore test will be added to that. Yes, I trust. Okay, this is a blank project. And if you look at YAML, all good. I will go to my main code and let's run this and see whether this is having any problems. So I'm going to use Edge browser. I'm waiting for the launch. Okay, I can see the program is running, no problem. Right. Now I'm going to replace this code with a new set of code. Yeah. If you remember the basic code when we generated Flutter, we got a counter. It was a counter app, right? Where this is the code, by the way. I just copy pasted the counter app. This is automatically generated. Let me show you how it looks. Okay, so this is how it looks. So there is a plus sign. When I press it, this number will be incremented. There. Okay. So now to get the number incremented, I have to press the button, isn't it? I have to press the button. So I am going to write a test case where the pressing of the button will be automatic. How do we do that? Well, let's see. This is widget testing, right? So to do that, I need a test case. Also, if you notice here, I have a folder structure, isn't it? Now, I don't have the test folder here, which I had in my Dart project. So if you remember Dart project, where just a minute ago, so we were doing our unit testing. In that, we have a test folder. But here, you don't see a test folder here. So I'm going to create a test folder. Actually, it should be in the root folder. So test, right? Here's the test folder. Inside that, I need a file. So let's call it widget one test dot. Now, widget one is the name of my widget I'm going to test. So that's my test case. Okay. Widget one test. So now here, I am going to bring in some code. So basically, okay, let me just copy paste that code and talk about that. All right. So, oh, I need to do a bit of cleanup. I have package Flutter test. I have my Flutter project, which is actually wrong. So this is widget one is the name of the project. So I need to replace this with widget one. Okay, so that's where my main dart is. So, all right, now I have a main. By the way, this is my test code. Okay, inside that I have my main code. So I have test widgets, count increment is the name I'm giving, and then I have widget tester class I'm using. Okay, and there I have bunch of stuff. First, I need to build our app. Okay, so for that I'm using pump widget, and to that I'm passing the my app from main dart. So if you go to main dart, my app is a class I'm using. Right? This can be anything you want, but in my case, I'm using my app. And in this, I am expecting the text to be 0. All right, verify that our counter start as 0. So first we are checking, is it 0? And then what are we doing? We are sending a tap event. Tap the plus icon and trigger a frame. So when I do that, of course, to tap, I had to find the icon, which is add. Now go here. You notice we have an icon, right? Icon add, this line. So that is what we are locating and clicking or tapping. And then we are triggering the frame by calling the pump function. And in the beginning, it was 0. After tapping, it should be 1, isn't it? So if all is good, this should work. So let me go back to my terminal. Right, here's my terminal. And let's say Flutter test. Something going on. This is the time, 5 seconds, 6 seconds. There you go. All tests passed. I didn't do anything. Everything was automatic. Right? Now, what if the original number is not 0? Or what if the expected output is not 1? We know by pressing the button, it should increment to 1. But for some reason, let's say here, where is my code? Okay, so what if this reason, so here the counter is 0. So I'm gonna do this and say count equals 5. When I press the plus button, what will happen now? My test will fail, right? So let's see. So what I did was, rather than incrementing the counter, I assigned number 5 to it. There, it failed. It says, okay, let's see. Count increment, exception caught by Flutter test framework. The following test failure was thrown running a test. Exactly one matching node in the widget tree, actual 0 widget with the text 1. So there is no widget having the number 1, obviously, because what I had was number 5. When the exception was thrown, this was a task. Okay, so counter increment, there is a failure. So let's look at my code, because I increase, or rather I change my code. So where is my output? Right, here's my code. Let me press the plus sign. Okay, it becomes 5. I press again number 5, because I'm assigning number 5 to it. Yeah. So my program fails. So I will rebuild the code with the plus plus. So now when I press this, it is incrementing. Now see, I simulated this clicking with the widget test framework, right? So that's the beauty of automatic testing. So let me clear the screen. Flutter test. This time it will pass. All tests passed. There you go. Okay. Okay, there's a good question from Ishan. When we give the Flutter test command, how does Flutter know which widget to test, right? Now, if you notice my file naming, I have a main dot. Look at the project name, it's widget 1. And in my main dot, I have a my app widget, right? So I am testing my app here, which is basically calling the counter widget, extending the stateful widget. And there I have a counter state, extending something called a state class here. Inside that, I have my visual widget, right? So in my test, I'm calling that here, my app. So if you want to test another one, another widget, you need to create another test case here, widget 2 test, and then pass the name of the widget you want to test. Okay, so that's how you test multiple widget. And when you say Flutter test, it will test everything inside the test folder. Whether you have 1 or 2 or 3, whatever, it will test everything one after the other. Okay, that's how it tests. Same thing can be said for unit testing. When you have multiple unit tests inside the test folder, it will go through each one. So this is the convention where if you want to test, put it inside the test folder. Okay, so that's how it works. Any other question, anyone? Right. So I'll share this code in my blog, so you can have a look at it as to how it works. Try that. It's fantastic. So this is one more reason why we are using Flutter and Dart in developing mobile applications. So a lot of things can be automated. Right. So there are other things I did not do, like the integration testing and also mock-up testing. Of course, I'm sharing some of the links. You can go find out more about it. So these are some of the areas where you will be tested on with your final exams. So please write the code, test it yourself. Don't try to memorize the code. That won't work. You can't memorize the code. You have to type this, run this, and then observe what is going on. So change things, write another widget, write another test case, and see how it works, how it behaves. Right. So that's how you learn your coding. Right. So I guess that's all for today. So we looked at testing of the mobile applications. We looked at lots of different theories under testing. So these are the areas we looked at. Unit testing, widget testing, integration testing are the main three ways of testing. Then we looked at concept called test-driven development, mocking dependencies, CI, code coverage, test suites and grouping, documentation, and also documentation testing, and also Flutter DevTools. All right. So when it comes to production work, you will learn a lot more about it. But at least these first two, you must know how they work. I think the mocking is also another one you need to master before you joining an organization for Flutter development. All right, I guess that's all for today. I'll see you next time. There was a question regarding exams as to how it looks. Yeah, I will discuss the exam structure later. I'll let you know how it looks. There will be a sample paper for you to have a look at it. So be in touch. Check out the LMS. You will know what I'm sharing there.